Okay, this is a lesson over, it's 8.2. It's using the angle-angle similarity theorems. Okay, previous vocabulary would be similar figures and similarity transformation. In this, we're going to use the similarity theorem that is the angle-angle, and we will solve some real-life problems. Okay, here it is for our first theorem. Only theorem that we have during this chapter is, or this section, is the angle-angle similarity theorem. If two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. Here we're saying that angle B is congruent to angle E, and angle A is congruent to angle D. Those two are congruent. We have two angles that are congruent, so we can use the angle-angle, hence AA, similarity theorem, and say that these two triangles are similar. Here's an example. Looking at these two triangles right here, we can say that angle D is congruent to angle G because they are both right angles. Then if we go ahead and look at this triangle here, we know that there's 180 degrees in every triangle, so if we add our 90 plus the angle that is 26 together, we'll get a total of 116. And we can subtract that from our 180 to find the measure of that other angle. It gives us 64 degrees. So angle E is 64 degrees. So if we look at angle E and angle H over there, they would also be congruent. So we can say that angle E is congruent to angle H. Therefore, since we have two angles that are congruent in these two separate triangles, we can say that these two triangles are similar. So we need to write our triangle similarity statement. Triangle EDC would be similar to triangle HGK. Okay, let's go do another example. Okay, we need to state that these two triangles are similar. Well, actually, they're already stated that they're similar. We need to show it. So if we look at this first one, they both have given us that they're 52 degrees right there. So we can say that angle B is congruent to angle C. Then we have to find another angle in there that would be similar. If you see up here, they both share angle A. So we could say that angle A is congruent to angle A. Then we have two angles that are congruent in both of those triangles, so the triangles are similar. On the next one, we know that vertical angles are congruent, so we could say that angle SVR would be congruent to angle UVT. There's one angle. But then if you look over here with our arrows, it's telling us that we have parallel lines. So if we go with parallel lines and a transversal over here, we can also say that this angle S up here would be congruent to our angle U down here because that is our alternate interior angles. So let me go and erase some of that so that you can see that better. Then we can go ahead and come over here and say that angle S is congruent to angle U because we had alternate interior angles. So we can put those together, and we also have these together right there. So we have two angles in these triangles congruent, so it would mean that they are similar. Okay, let's try some real world examples. My picture got kind of messed up on here, but on y'all's paper it should be fine. The woman should be standing over here, just like on your picture, and she kind of got scooted over, sorry. Anyway, it says a flagpole casts a shadow that is 50 feet long. At the same time, a woman standing nearby who is 5 feet 4 inches tall casts a shadow that is 40 inches long. How tall is the flagpole to the nearest foot? Okay, so if we go and do this, they said that the shadow cast by the flagpole was 50 feet. And we don't know how tall the flagpole is, so we can make that X. The woman's shadow was 40 inches. And her height was 5 feet and 4 inches. So we can go ahead and set this up. We can do the height on one side. So if we go ahead and set this up, we can do the flagpole. height over the woman's height would equal flagpole shadow over woman's shadow. But let's go ahead and change her height. Let's go ahead and change that to inches. So if we change 5 inches, or 5 feet 4 inches into just inches, we would have 64 inches. So we're going to use that for our height over there. So if we do it and set it up just like that, the flagpole's height is what we do not know. Over the woman's height. The woman's height, we're going to use the 64 inches. And then over here for the flagpole shadow, we know that we had our 50 feet. And that would be over the woman's shadow. Well, the woman's shadow is 40 inches. And I'm going to erase that other part now because y'all already should have had that, so I can have more room. Okay, if we go ahead and cross multiply and then divide, we would end up getting that the flagpole should be 8 feet tall. Okay, let's go do another real world example. Y'all have a picture already on y'all's, but for some reason my picture messed up and didn't get on here very good, so I just went ahead and redrew it. Sorry. Okay, it says, same basic kind of concept. A tree casts a shadow that is 45 feet long. So my tree's shadow is 45 feet. Same time, a boy who is 5 feet, 8 inches, casts a shadow that is 51 inches long. How tall is the tree to the nearest foot? So the tree's height is what we need to know. So we can set it up just like we did a while ago. We can have tree height over boy height would equal tree shadow over boy shadow. I'm giving you a couple minutes to get that written because I'm going to erase it and use that space for our numbers. Okay, so we don't know the height of the tree. There's our X. We know the height of the boy. If we go ahead and change that just 2 inches, it should be 68 inches. So the height of the tree we don't know, and the boy's height is 68 inches. Then we can come over here and say the shadow that the tree casted was 45 feet, and the shadow that the boy casted was 51 inches. So then we can go ahead and cross multiply and divide. And when we do that, we should get that the tree was 60 feet tall. Okay, we'll have some more examples and stuff that your teacher will do with you, but basically this is what we need to do on our angle similarity problems.